Hey guys, in today's video I will show you how to take the derivative of natural logarithm functions or natural log functions. Something like ln of 6x, ln of 3x plus 1, or it could be more complicated, ln of something like 7x plus ln of x. I will go through all of these cases one by one and I will show you how to handle them. Now, let's have a look at the first one. Say you have been given ln of 6x and you need to find the derivative of this function, or in other words, you need to differentiate this function with respect to x. All you need to know is that the derivative of ln of u is 1 over u. This comes from the standard table of derivatives, and I'm using u in this case for this rule in order to emphasize and highlight that u could be any expression containing x. It could be any function in terms of x. So u could be another function. And since u potentially contains this x, you have to apply the chain rule. Again, we get back to this chain rule, which came back to haunt you. Now, all you do for the derivative for the first one, and I'm going to use this prime notation, this is standard notation that stands for the derivative of the function. All you do is just take this one over the entire argument. So the argument of your function is 6x. So 1 over 6x. And again, if you look at your original function, it's ln not of x, but ln of something more complicated, more complex than x. It's ln of 6x. And again, the chain rule, recall that the chain rule basically asserts all you do is just take the derivative of the outside function of your outer function. And in this case, your outer function is gonna be ln, basically for all of these cases, since ln comes first. The inner function, what is inside, it's 6x in this case. So we need to take care of the derivative of 6x, of this inner function. So this gets multiplied by the derivative of 6x. So times 6x prime. Do not forget to add this component, this element, the derivative of 6x. That's vitally important according to the chain rule. All you need to do is just clean it up and recall that the derivative of 6x, it's going to be just 6. You are left with 1 over 6x times 6. And this 6 and this 6 in the denominator, they cancel each other out beautifully, so 6 goes away. And you end up getting just 1 over x. So basically it's the same result, it's the same function as is for ln of x. So ln of x and ln of 6x, the derivative would be the same. Little bit weird and peculiar, bizarre, probably, but because we use the chain rule, so that's the moment where chain rule pops in and kicks in. So that's why the derivative is going to be 1 over x. Moving on, ln of 3x plus 1. The same idea, precisely the same idea applies over there. All you do for taking the derivative, first of all, you have outside function, which is again ln, and you have something inside. So this something inside is this entire parenthesis. It's the linear expression, linear function in terms of x. So namely 3x plus 1. So first of all, the derivative of ln, it's going to be 1 over 3x plus 1. And again, I'm going to rewrite the whole entire argument. I'm going to place it in the bottom of this fraction. And this one gets multiplied by the derivative of 3x plus 1. And since the derivative of 3x plus 1 is going to be just 3, since the derivative of 1 is just 0, so this one goes away. So this term gets multiplied by 3. Again, 3 comes from the derivative of 3x plus 1. And at this point, you cannot simplify any further. All you could do is just place this 3 on top of this fraction, and your final derivative, your final result becomes 3 over 3x plus 1. That's going to be your derivative, or your derived function, if you will, for the second one. Here's the last one. Say you have ln of 7x plus ln x. So your outside function is going to be ln of x, and this entire parenthesis, namely 7x plus ln x, is going to be your inner function, something what you have inside your complicated, your complex, or your composite function, if you will. First of all, the derivative of ln, again, it's going to be 1 over. So 1 over this entire parenthesis I'm going to place in the bottom of this fraction. So 7x plus ln x goes in the denominator. And we are not done yet, since again, I do sound like a broken record. Since you have this inside function, you have to take care of the derivative of this inside function. So it's 7x plus ln x, and this term gets multiplied by the derivative of this. I'm going to put the parentheses, since you have 2 chunks, 2 terms inside. Your inner function basically is made of 2 pieces, 2 chunks. So you have to take the derivative of the first chunk, namely 7x, and the derivative of 7x is going to be just 7. You want to keep this addition, plus sign. And the derivative of ln of x is going to be 1 over x. So plus 1 over x. This is a little bit weird, little bit different from what we did before. The previous 2 cases was the basics kinds, if you will. And we are done with the derivatives. All you need to do is just apply your basic algebra skills to clean it up. We don't want to leave the house like this. All you want to do is I would just get the common denominator inside the parentheses, and I'm going to rewrite the first term as is at this point. So it's 1 over 7x plus ln of x times, so the common denominator is going to be just x, and 7x plus 1 goes on top. And I believe the last step, I'm going to just multiply, since you are given 2 fractions and you have multiplication sign between them. I'm going to multiply the tops straight across, and I'm going to multiply the bottoms straight across, and there is nothing you can do with this function. So it becomes 7x plus 1 goes on top of this fraction, this final result, the final derivative, and I'm going to place x first, parenthesis 7x plus ln x goes inside. The only you can do, you could expand the parentheses, you could remove them and open it up by taking this x and distributing over these 2 terms inside, but for me it's totally fine. You could do this expansion if you have to, or if you want to. It's completely up to your whim. Anyway, it's gonna be your derivative for this function. Alright, I hope it has been helpful to you. And by the way, I do have a couple of videos on finding the derivative for exponential functions. The idea, the steps, kind of similar. And if you need this extra help with taking the derivatives of exponential functions, there are a bunch of videos on this, and I will link them down below in the description box. And if you need this help, if you're up to this, go ahead and check it out. Alright, I hope it has been helpful to you. Huge thanks for watching, and tell your brain, I know everyone hates math, but if you like my video, please hit this like, share with your friends, leave the comments down below, and be sure to smash that subscribe button. Also turn on this notification bell so you will not miss out my new uploads.